find the direction cosines of two lines which are connected by the relations. This is one problem and this is another second bit. So one bit I'll do, you can try the second one. Okay? So first bit solution. So how we do is, you are given the equations L minus 5m plus 3n is equal to 0. Number this as equation 1 and 7l square plus 5m square minus 3n square is equal to 0. This is second equation. Now what you do is, always one equation will be first degree like this in LMN and second equation will be in second degree equation. L square, m square, n square equation or LM, MN, LN equation like this. So we'll do one problem of this type and another problem of that type again in the next type of problem. So here if you are given like this. So from first equation you find out any one, either L or M or N, anything you can find out. Here it is easy to find the L value because it has coefficient 1. So L is equal to, so from equation 1 implies L is equal to 5m minus 3n. Now what you do is substitute. Substituting in second equation we get 7l square, 7 into 5m minus 3n whole square, 7l square plus 5m square minus 3n square is equal to 0. Now expand this. So you will have 7 into, this is 25m square plus 9n square minus 30mn. 30mn plus 5m square minus 3n square is equal to 0. Now simplify. 25 into 7. 175m square plus 63n square minus 210mn plus 5m square minus 3n square is equal to 0. Now simplify. 175m square plus 5m square. So it is 180m square. And then this is minus 210mn. And this is 63 minus 3 is 60. So 60n square is equal to 0. You can take 66, 30 you can take common. 60 you can take common. No? 60 into 6, 3m square minus 6. Okay, I'll take and first I'll take 30 common and we'll see 6m square 7mn plus 2n square. Okay, only this. You can take only 30 common. So that means it means 6m square minus 7mn plus 2n square is equal to 0. Now find the factors for this. 6 2s 12, 7. 12, you must find the factors. 4 and 3. 4 3s are 12. So you can write 6m square minus 4mn minus 3mn plus 2n square. Find the factors. So you can take 2 common from this, 2m common. So 2m into 3m minus 2n. 3m minus 2n. Here you can take n common minus n common. When you take n common, it is 3m and minus you have to take common. So minus 2n is equal to 0. So that means 2m minus n. 2m minus n into 3m minus 2n is equal to 0. These are the factors. Now it means that, so it implies that, I'll write here. So it implies 2m minus n is equal to 0 or 3m minus 2n is equal to 0. Now we'll take two cases. Case 1. So we'll take, suppose case 1. Suppose that 2m minus n is equal to 0. So then you will get n as equal to 2m. 2m is equal to n. Now we'll find out L from this. So from 1 we'll get, from equation 1, we get L is equal to 5m minus 3n. That is 5m minus 3 into n. What is n? 2m. So whichever is convenient you find out. Here because it is n coefficient is 1, we found n value. Otherwise you can find m value later. So this is what? 5m minus 3 to 6m. So that is minus m. So now all are in terms of here. So what is L is to m is to n. L is minus m. M is m only. We'll write m as m only. And n as 2m. Because we have L and n. L and n in terms of m. So m you write as m only. You are taking the ratio here. So these are the direction ratios. These become now the direction ratios. So you can just cancel m and you can write this as minus 1 is to 1 is to 2. So after writing like this, you can write, therefore the direction ratios, the DRs of one line, the DRs of one line are A1, B1, C1 is equal to minus 1, 1, 2 like this. You can just write the ratio values as I already tried. They become the direction ratios of one line. Okay, now you take case 2. This is case 1. Now you take case 2. So, what is the question? You must find the direction cosines of the two lines. These are just the direction ratios. So now you find the root of a1 square plus b1 square plus c1 square. So what is it? Root of minus 1 whole square, that is 1. 1 square is 1. 2 square is 4. So when you simplify it is root 6. So now when you know this is another point which we must, when you know the direction ratios, you can find the direction cosines by dividing each of them by root of these squares, sum of the squares. So the DCs of one line, are, what is it? Minus 1 by root 6 and then 1 by root 6 and then 2 by root 6. So this is one value. Next case 2. We'll take case 2. So suppose we'll take 3m minus 2n. 3m minus 2n is equal to 0. Then from this you can find either m or n. We'll find out m here. M is equal to 2n by 3. Now again from equation 1 we'll get L is equal to 5m minus 3n. So what is 5m? 5 into m is 2n by 3 minus 3n. So this is 10n minus 9n by 3. So that is n by 3. Now we'll find again L is to m is to n. So what is L? N by 3 is to m. M is 2n by 3. 2n by 3 is to n. So you can take n common and cancel. So it is 1 by 3 is to 2 by 3 is to 1. Now multiply the whole ratio by 3. Then it becomes 1 is to 2 is to 3. Now you find out root of 1 square plus. So these are the, so therefore we'll write. Therefore the direction ratios of the second line, direction ratios of the second line are A2, B2, C2 is equal to 1, 2, 3. Now just to find root of A2 square plus B2 square plus C2 square. So that becomes 1 square plus 2 square plus 3 square. So 1 plus 4 plus 9. So that is root 14. Now we'll write. Therefore, the direction ratios of the second line are, so we'll write, therefore the direction ratios, the DRs of the second line, are 1 by root 14, 1 by root 14, 2 by root 14, 3 by root 14. So finally you should write now. Therefore the directions cosines. These are the ratios. Therefore the direction cosines of the two lines are. So what are the direction cosines of the first line? Minus 1 by root 6, minus 1 by root 6, 1 by root 6, 2 by root 6. And this 1 by root 14, 2 by root 14, 3 by root 14. So this is your answer. Okay. So the procedure is like this. First you are given two equations. Just understand the procedure and think that way. You can solve any type of problem. So you are given two equations like this. One equation will always contain L, M, N. You find out either L, M or N. So here we found L. We substituted in the second equation. Then we'll find the factors. We always get two factors like this. Now first factor is equal to 0. Consider first factor is equal to 0. Whichever you find convenient, that value you find out. And then substitute in this equation and find out the other value. Then take the ratios. Then they become the direction ratios of the first line. To convert them to direction cosines, you take the square root of the squares of this a1 square, b plus b1 square plus c1 square. Find the value. Then you will get the direction cosines of first line. In the same way, you find the direction cosines of the second line. So here we got fraction. Let it be. Let there be fraction. Still you can simplify. So L value is also a fraction like this, n by 3. Then whatever is common, you just cancel out. And then denominators, to find the ratio in the simplest form, you will take the LCM of the denominators. Here the LCM is 3 only. So multiply all the ratio values by 3. Then you will get the ratio in the simplest form. Then write the direction ratios. These values become the direction ratios of the second line. Then you find out this value and then write the direction cosines of first line and direction cosines of second line like this. Okay. So now in the second problem you can find either L or M or N. You can find either L or M or N. So suppose I find N and all. If you find N, you will get different equation. If you find L, you will get a different equation here like this. So finally, I'll just give the answers. The answers for this problem are, the direction cosines are 1 by root 6, and then minus 2 by root 6. And then another line direction cosines are 1 by root 6, minus 2 by root 6, and then 1 by root 6. So these are the values for the second bit. You can try, you can take it as homework. Now we have another two problems which are similar to this. So you will be given again same two equations and you have to find the angle between the two lines. So to find the angle also, you need the direction ratios. You don't need any direction cosines. You can use cos theta formula, a1 a2 plus b1 b2 plus c1 c2 by root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square. So you can use that formula. If you are finding the direction cosines, then you will use the formula cos theta is equal to L1 L2 plus M1 M2 plus N1 N2. So if you are finding the angle, to find the angle, you must find the direction ratios. That is enough. We can just use cos theta formula. So next problem, find the angle between the lines. Now find the angle between the lines whose direction cosines satisfy the equations. This is one bit and this is the second bit. We'll do the second bit now. So what is it? First we'll take the equations. We are given, given equations are 3L plus M plus 5N is equal to 0. This is first equation. And 6Mn minus 2NL plus 5LM is equal to 0. Second equation. Now what we do is, from first equation you can find either L or M or N. Here it is easy to find M value because its coefficient is 1. So from first equation you will get M is equal to minus 3L. Minus 3L minus 5N. Now substituting in second equation. Substituting in second equation we get 6Mn. 6 into M. M is minus 3L minus 5N. 6M into N minus 2NL plus 5LM. M is again minus 3L minus 5N is equal to 0. Now we should simplify this. So it is 6 3 is 18 minus 18L. N is also there, Ln. Then minus 30N square minus 2, I'll write Ln here also, Ln minus 15L square minus 25Ln is equal to 0. So now it is 15L square minus 15L square and then 18, 20, 45. So minus 45 Ln minus 30N square is equal to 0. You can take minus 15 common. Then it becomes L square minus 3 Ln plus. You have taken minus outside now. So 15 2 is 30. So 2N square is equal to 0. So that means L square plus 3Ln plus 2N square is equal to 0. Now you find factors. 2 ones are 2 plus 1 you can write. So L square plus 2Ln plus Ln plus 2N square is equal to 0. Okay, from these two we'll take L common. Then we'll get L plus 2N. And from these two we'll take N common. Then we'll get L plus 2N is equal to 0. So that means L plus N into L plus 2N is equal to 0. So it means that L plus N is equal to 0 or L plus 2N is equal to 0. Now we'll take case 1. Suppose that, like in the earlier problem, same procedure, case 1. So suppose that L plus N is equal to 0. So that means L is equal to minus N. L is equal to minus N. Now we'll find out in the third, this equation. We'll substitute in this equation. So we'll number this as 3 otherwise. Okay, substituting in 3 we get, so substituting in 3 we get m is equal to, okay, we get m is equal to minus 3 into minus n, 3l, l is minus n, minus 5n, that is 3n minus 5n, minus 2n. So now we'll find L is to M is to N. L is minus N is to M is minus 2N is to N. So that is minus 1 is to minus 2 is to 1. So now we'll write. Therefore, the direction ratios, the DRs of one line, are A1, B1, C1 is equal to minus 1, minus 2, 1. Okay. Now we'll take case 2. Suppose that L plus 2n is equal to 0. Now substituting in equation 3 will get M is equal to minus 3. From this we'll find out L. So L is equal to minus 2n. Okay, so minus 3 into L. L is minus 2n. Minus 3L minus 5n. So that is 6n minus n. That is n. So now we'll find L is to M is to n. So L is minus 2n is to M. M is n is to n. So that is minus 2 is to 1 is to 1. Now we'll write. Therefore, the direction ratios of the second line. Are A2, B2, C2 is equal to minus 2, 1 and 1. Now we'll take, let theta be the angle between the two lines. Let theta be the angle between the two lines. Then cos theta is equal to, you know the formula, mod of A1 A2 plus B1 B2 plus C1 C2 by root of A1 square plus B1 square plus C1 square into root of A2 square plus B2 square plus C2 square. Now substitute the values. A1 is this, 1 minus 1. So minus 1 into minus 2. A1 A2 plus B1 B2 minus 2 into 1 plus C1 C2. 1 into 1 by root of minus 1 whole square, 1 plus minus 2 whole square plus 1, like this. Root of, this is again 4 plus 1 plus 1. Root 6 into root 6 is 6. And here this is 2, this is plus 2 minus 2 gets cancelled. So I'll get 1 by root 6. So theta you must find out. Therefore, the angle between the two lines is, therefore, the angle between the two lines is cos inverse of, theta is equal to cos inverse of 1 by root 6. So this is your 1 by 6. Root 6 into root 6 is 6. So it is 1 by 6. That is the answer. Cos inverse of 1 by 6. Okay, so this is the procedure. Like in the earlier problem, you will find the direction ratios. Here, direction ratios are enough. Direction ratios of first line, direction ratios of second line, and substitute. This problem is very, very important. And for the first problem, the answer is theta is equal to 60 degrees. For first problem, you will get theta as 60 degrees. Same procedure. I will continue in the next period. So the vertices of a triangle are given. Find the angles A, B and C. That is one problem. So these are also very important for 7 marks. Another problem is you are given again the vertices and then find the direction ratios of the sides. Then determine whether it is right angled or isosceles. So like in first problem, here also you will find out all the 3 angles. If 2 angles are same, then you will say that it is isosceles. If you get one angle as 90 degrees, you will say that it is right angled. So you will find out whether it is right angled or isosceles by finding all the 3 angles like in first problem. So you can try the second problem and do the first one. So these are on page 149 in the textbook, third section, 6th and 7th problems. So I'll do the 7th problem solution. So in the 6th problem, you take the vertices as A, B and C letter. So let A is equal to 1, 4, 2, B is equal to -2, 1, 2, and then C is equal to 2, 3, -4 be the vertices of triangle ABC. Be the vertices of a triangle ABC. Now you must find the angles between angles A, B and C. So A is the angle between AB and AC. A is the angle. This is the angle. This angle is between A is the angle between the sides AC and AB. So we'll take AB direction ratios, AC direction ratios, and then apply that formula. So DRs, direction ratios of AB. What are the direction ratios? Direction ratios of side AB. Of side AB are x2 minus x1. x2 minus x1, comma, y2 minus y1, comma, z2 minus z1. So there, if you subtract x2 minus x1, -2 minus 1, -3, and then 1 minus 4, -3, 2 minus 2, that is 0. So you take them as it is like this. Now, next is direction ratios of a side AB next to BC. So what are the direction ratios of BC? Same formula. So 2 plus 2, 4. And then 3 minus 1, 2. And then -4 minus 2, -6. So these are your A1. If you take them as A1, B1, C1. And this as A2, B2, C2. And then the direction ratios of side AC or CA, anyway you can take. So 2 minus 1 AC, so 2 minus 1, 1, and then 3 minus 4, -1, -4 minus 2, -6. So these are A3, B3 and C3. Now if capital A, capital B, capital C, capital A, capital B, capital C are the angles of the triangle, or first we'll write A is the angle between AB and AC. A is the angle between AB and AC. AB and AC. So therefore, cos A is equal to what are the direction ratios of AB? A1, B1, C1. Direction ratios of AC, A3, B3, C3. So write the formula as A1, A3 plus B1, B3 plus C1, C3 by root of A1 square plus B1 square plus C1 square into root of A2 square plus B2, A3 square. A3 square plus B3 square plus C3 square. So now find out A1, A3. A1, A3 means -3 into 1. Modulus of this. So -3 into 1 is -3 and then plus 3 plus 0. So we are getting the angulus. Yes. -3 plus 3 plus 0 by root of. So this is root of 16 plus 4 plus 36. And then again root of 1 plus 1 plus 36. So it is equal to 0. 3 gets cancelled and 0. So 0 by any number is 0. 0 can be written as cos pi by 2. So that means A is equal to pi by 2. So one angle we find out. Now in the same way we'll find angle B. B is the angle between what sides? B is the angle between BA and BC. B is the angle between BA and BC. So BA or AB direction ratios are same. So we can write cos B is equal to what is BA or AB, same direction ratios. So it is A1 and for BC it is A2. So the formula is A1 A2 plus B1 B2 plus C1 C2 by root of A1 square plus B1 square plus C1 square into root of A2 square plus B2 square plus C2 square. So now multiply A1 A2 means minus 3 into 4 minus 12 and minus 6 plus 0 by root of 9 plus 9 plus 0. AB and AC. Root of this is correct, 1 plus 1. This is wrong here, yes. So here actually it should be 9 plus 9 plus 0. But anyhow it is 0. So okay. So 9 plus 9 plus 0 into root of A2 square. Cos B. A2, B2, C2. What is A2, B2, C2? So 16 plus 4 plus 36. So you will get minus 18 by mod. When you take modulus, it becomes plus only. So 18 by root of 9 to 18 into root of 40, 56. Root 56. So 1 root 18, you can write as root 18 into root 18. And 1 root 18 gets cancelled. And it is root of 18 by 56. So 2 9s are 18. So root of 9 by 2 8 is 16. So root 9 is 3. 3 by root 28 can be written as 4 7s are 28. So 2 root 7. So like this you can do. So therefore cos B is equal to B is equal to cos inverse of B is equal to cos inverse of 3 by 2 root 7. So this is one answer. Now C is the angle between I'll write it up. So C is the angle between CA and CB. So cos C is equal to CA. CA or AC is this. CA and CB means this. So the formula becomes A2A3 plus B2B3 plus C2C3 by root of A2 square plus B2 square plus C2 square into root of A3 square plus B3 square plus C3 square. So that is equal to A2A3 means 4 minus 2 plus 36 by root of BC. So root 56, that is root 56, and AC is 36, that's 38, root 38. We'll get like this. It is root of 38 into 38 by 56 into 38. 138 gets cancelled. And then when you simplify it, when you cancel 2, it becomes 19 by 2, 2s are 4, 2, 8s are 16 like this. So that means cos C is equal to this, no? So C is equal to, implies C is equal to cos inverse of root of 19 by 28. So like this we find all the 3 angles. Procedure is same, but you are finding the angles 3 times. A is the angle between AB and AC. B is the angle between BA and BC. So accordingly, you just substitute the values and finally you write. Therefore, the angles of the, after this step, you write. Therefore, the angles of the triangle are, we'll write. The angles are, angle A is equal to 90 degrees. Angle B is equal to cos inverse of 3 by 2 root 7 and C is equal to cos inverse of root of 19 by 28. This is your answer. Okay. Now in the same way, you find the angles here in this second problem, and then you can see that one angle, it is right angled, it is not isosceles. In the same manner, you find the three angles